Hello, all. I wanted to take a minute here, go through a couple of examples of how to get through this, and just kind of remind you of some of these terms. If you don't have with you a periodic table, I think you're going to find that that's helpful. As mentioned before, you'll never need to memorize the periodic table, and I actually encourage you to jot down little reminders of some of the things that we've gone through. I get that there's a lot of terminology in this unit, and if you're still kind of trying to piece it together, where if I ask you about an atomic number or atomic mass, or how do you calculate neutrons, or which one has the charges or the mass, that's a lot to pull together. So as long as you know how to use that information, I'm kind of more concerned with that than I am the memorizing. And, full disclosure, I found that the memorization just kind of happens if you go through the practice. So I haven't put it on here yet. But I don't think it'd be a bad time to just sort of say, okay, well, we got protons, and they've got a mass of 1 AMU, and they're positive charged. And then we got neutrons, and they got 1 AMU, and they have a neutral charge or no charge. And then we got electrons. And you might remember from lecture, I was saying we're just going to say it doesn't have a mass, which isn't really accurate, but it'll be fine to get us through this unit. So the AMU, that's the unit that we're using for these subatomic particles. And I hope that these little symbols look familiar as well, because they've been discussed. This is just a way to abbreviate, protons, and then the plus in subscript is because it has a positive charge. Neutrons. A lot of times kids will think, oh, it starts with an N, negative. No. Neutrons, neutral, hence the 0 that's supposed to indicate no charge. And then we got our electrons, and they are negative charged. So keeping this straight is helpful, because there's times where we say, hey, let's take a look at charge. And when we're looking at charges, I'm not going to say the neutrons don't matter, but they don't have a charge. So if we're really adding or subtracting neutrons, that's not really going to change much because there's no charge. But there's other times where we might say, let's take a look at the mass. And in those cases, well, we're saying electrons don't have mass. So if we're adding or subtracting electrons, that's not really going to affect the mass there, right? It's going to affect the charge, whereas the neutrons tend to affect the mass. And you may recall also with the protons, remember we got atomic numbers. That is the number of protons. You can't change that. That's going to be what makes an element that element, or gives it its identity. Cash. Why is nitrogen nitrogen? Because it's got 7 protons in its nucleus. What about sodium? Well, sodium because it's got 11 protons in its nucleus. Oh, well, what if this sodium had a positive charge and we added a proton? You can't. You would have just turned sodium into magnesium, and that can't be. So these terms, again, depending on where you're at or how much you've reviewed, they either mean a lot or a little or perhaps nothing. But when we talk about a neutral atom, I'm just going to say that that's when your protons equals your electrons. And a neutral atom, that's in reference to its charge. So I sketched out the little picture for you in lecture there, right? Where I was like, hey, think of it as kind of like a teeter-totter. And if I've got like protons, a number of protons within an atom, and electrons, a number of electrons orbiting around in that atom, if there's the same amount, it's neutral or it's balanced or there is no charge. What if you have more protons? Be positive charged. And we'll look at that with ions. How's about electrons? Well, then it's got a negative charge if there's more electrons than protons. And I know that this is getting ahead of myself a bit because we haven't talked about ions. But again, when we look at positively charged ions, you can't change protons or add in more protons. If I said, well, boron has a positive charge, well, then I'm going to have to get rid of electrons. If I'm losing you with that, I apologize. I'm kind of getting ahead of myself. Let's just stick to the task at hand. So our protons, I'm going to say that these are positively charged, and they've got 1 AMU. Electrons, these are negatively charged, and they've got 0 AMU. That was supposed to be a little dash there. Apologies if that looks like -1 AMU. That was supposed to just be they positive and equal. Maybe I'll do that there. I'm not trying to confuse anybody. Electrons have a negative charge, and we say they have 0 AMU. Our neutrons are neutral, and they have 1 AMU. So I didn't put them on here, but just again, a little quick review here from the lecture. Remember, you've got your protons and your neutrons that live in the nucleus. Oftentimes, these guys are referred to as neutrons, because they're going to be, nucleons, because you've got your neutrons and protons within the nucleus. And then do the genius work of Niels Bohr. We're kind of just working with basic Bohr models. Electrons orbit around the nucleus. The atomic number equals the number of protons. So those are always the same. What's the atomic number? It's the number of protons. Where's the atomic number come from? The number of protons. And the atomic mass, that's going to be the mass of the atom. Well, where's that come from? Well, remember, protons have a 1 AMU mass, and neutrons have a 1 AMU. So in a previous discussion, I said you might want to jot down, if you got to calculate neutrons, that it's the mass minus the protons. Whatever you're left with, that's going to give you the neutrons. And another thing that we discussed in previous lectures was you want to round this mass. I'll get into why there's a decimal or like that leftover change on each of these at a later date. But for right now, I just want you thinking you can't have like a fraction of a proton or an electron or a neutron. You either have a whole one or you don't. There's not like a sort of vanadium here, right? So 50.94, that doesn't mean that there's 0.94 of something. We're going to round that up to 52. So looking at this, you've got some columns, right? There is element, that's just the name of the element. What its symbol is, that's going to be the abbreviation from the periodic table. And I know if you didn't catch this in Unit 1, some of them are wonky. Like if I look at iron on here, iron's symbol is Fe. Well, there's no F and there's no E in iron. Why would they do that? Well, ferrium is iron in Latin, and there's other languages that contribute to this besides English, so some of them are a little bit odd. The atomic number and the number of protons, remember, those are always the same. So I can actually kind of do one of these here just so that I remember that, right? And then I know that the atomic number is the number of protons. The atomic mass, that's your protons and neutrons, and we can just round that. We're going to assume that all of these are neutral. So like if I go back to my little teeter-totter there, that means if these are neutral, my protons and electrons are going to have to be the same. And then for the neutrons, I've got to calculate that. What? How do I do? Oh, yes, goodness gracious. I'm glad I don't have to memorize all this stuff. Neutrons comes from your mass minus the protons. Just make sure that you round the mass. So to do an example for you here, how would we get all this information for aluminum? Well, we got to scroll around and find aluminum, and it lives right here. So let's see if I can get all this in the screen for you there. Okay, so I've got aluminum, lives right there. The symbol for it is Al, and if you were thinking that was AI, new. The way that these work is your first letter's always capital, your second letter's always lowercase. If there happens to be a third letter after that, it's lowercase as well. That's going to be real important when we start writing compounds and formulas and things of that nature. For now, just trust me, aluminum's Al. The atomic number, in this periodic table, it's given to me in the top left here, it's 13. And I know that the atomic number is the number of protons. So I can backtrack here to atomic mass. On this particular periodic table, it's given to me underneath at the bottom here. And I'm just going to round now. Eventually, like I said, we'll talk about why this is a decimal. But if I've got $26.98, I'm pretty doggone close to 27. So I'm going to round that guy up. These are all neutral. We're going to say right now, all of these are neutral. Cash, what's that mean if something's neutral? It means that your positive and negative charges are the same. Okay, so if I've got 13 positives, I'm going to have 13 negatives. How do I figure out neutrons? Well, I can take the mass, subtract out how many protons there were, and I'm left with my neutrons. So if I've got 27 AMUs for this atom of aluminum, and 13 of those AMUs come from protons, that means the remainder there, or the leftover 14 AMUs, has to come from neutrons. And each neutron has a mass of 1 AMU. Sorry if that didn't show up there real well, but that's what I was working on. So here, what gives? How am I supposed to know what the heck this is? There's no name. Well, remember, atomic number, one of the ways a periodic table is organized is by atomic number. So if I scroll around to figure out who's 19, the only atom that we know of in the universe that's got an atomic number, element that's got an atomic number of 19, is potassium. Kind of weird, right? That one's K. That's the abbreviation. So what's atomic number 19? Potassium. And its symbol is K. So the atomic mass, right? I got to get that from the periodic table as well. This one's 39.10. I'm going to call that just 39. Number of protons for potassium. Well, I know that those are the same, right? How do I figure out the protons? It's the atomic number. Potassium is potassium because it's got that 19. And like I've said before, and I'll say again, you can't change the number of protons when we get down the road and we're looking at charged particles with the ions. Electrons, well, if this is neutral and I got 19 positives, well, then that means that I've got 19 negatives. And if this is 39 and 19 of it comes from protons, that means the last 20 AMUs has to come from neutrons, or there'd be 20 of those total. So really, you should be able to figure out each of these with the amount of information that's given. Protons. Well, I know protons are the atomic number. So who's 12? Magnesium. So magnesium's going to have 12 protons. And then from there, I can pull the information and just work it out like this. So that should be a pretty good start on getting you on the right path. If you've got questions, concerns, please don't hesitate to ask. Good luck in your calculations.